Question number 13 on the worksheet on forces on inclined plane. A rough plane is inclined at an angle alpha to the horizontal, where tan alpha is equals to 2.4. Okay. Now, if tan alpha is given, you should be able to find sine alpha and cos alpha as well, because we need it when we resolve components. So let me just do that working real quickly. So tan alpha is 2.4, that is 24 over 10, or simplified would be 12 over 5. Okay. Now, if I draw a right angle triangle here, so if this is alpha, tan is opposite over adjacent. This would be 12. This is 5. You use Pythagoras and you should be able to get 13 for the hypotenuse. 12 square plus 5 square, square root would give you 13. Okay, so that would mean that sine alpha would be opposite over hypotenuse. Cos alpha would be adjacent over hypotenuse. Okay, so now we know sine A and cos A as well. Okay, and it says that a small block of 0.6 kg is held at rest. Held at rest means that acceleration is 0. That means forward force is just equals to the backward force on the plane by a horizontal force of P newtons. Okay, usually in the question, this P is parallel to the slope, which makes the working a lot more easier. But this one is not parallel to the slope. So what we need to do is find its component that is parallel to the slope and find its component that is perpendicular to the slope like this. So we'll have to resolve this force. What we can do is we can make a line here and we can make a line here and get a right angle triangle like this. Now, if we follow this arrow, then the components would be in this direction. This would be in this direction, and this would be in this direction, following the arrows. Okay. Now, this angle here would be alpha. Why is that? Because alpha is between the horizontal line and the slope. And this is also the horizontal line, and this is the line parallel to the same slope. So hence, this angle here would be alpha as well. So we have alpha here. Now I'm going to resolve this triangle. I have a setup like this. If this is A alpha, this would be a right angle triangle and this would be P. So then this opposite side becomes P sine alpha and this side becomes P cos alpha. Okay, that is how resolving of forces work. So this would be P sine alpha, and this one upward would be P cos alpha. Let me rewrite this as, I'm going to redraw this, and I'm going to make this force downwards representing this. It's a downward force. I can just draw it from the block. This downward force is P sine alpha, and this force I'm drawing up the plane like this. This would be P cos alpha. Okay, let's clear this and this. Okay. Similarly, we'll have components of the weight, and we know weight has two components. One in this direction, which is always the cos component, which would be 10m cos alpha because of this angle. So we also have m, which is 0.6. So 10m is going to be 6. This would be cos alpha. And in this direction, we have mg sine alpha. So 0.6 into 10, which is 6 sine alpha. Okay. The coefficient of friction between the block and the plane is 0.4. Okay, I still have to figure out whether friction is going to be in this direction or this direction. That depends on the direction of movement. Friction is always opposite to the direction of movement. Okay, let me clear these. And this, okay, cleared. All right, so which direction is friction going to be in? This was the mg sine theta. Okay, By the block is on the point of slipping down the plane. Okay, so if it is on the point of slipping down the plane, that means it hasn't slipped yet, but when it will move downwards, which means that friction is going to be opposite. This is going to be the direction of motion, and this is going to be the direction of friction. Friction is given as mu r. Okay, and where's r? R is always opposite to the contact, so here. R is here. By resolving forces parallel to and perpendicular to the inclined plane, we have already done that, find the value of P. So now the plane is not moving yet. So what we're going to do, we're going to equate all the forces. So this force, 6 sine 10, is going to be equals to these two forces. Let me write that down. 6 sine alpha should be equals to P cos alpha plus mu r. We already know mu is 4, and r is going to be equals to these two because it's opposite to that and they balance out as well. So P sine alpha plus 6 cos alpha. Or let me write r for now, deal with it in a bit. This is equation 1. And then I'm going to equate these two. Upward force is equals to downward force. So R is equals to P sine alpha plus 6 cos alpha. This would be equation 2. Now we have to figure out a way to use these two simultaneous equations and find the value of P. Okay. Now what I'm going to do is I'm going to replace this sine alpha and the cos alpha in both the equations with this 12 over 13 and 5 by 13. Let's do that. So let me clear this. Okay. So sine alpha is 12 by 13. Let me write that here. Cos alpha is 5 by 13. And similarly, sine alpha is 12 by 13. And cos alpha is 5 by 30. Okay. Now what I'm going to do is I'm going to replace this r with this. So we get 6 times 12 by 13 is equals to 5p by 13 plus 0.4 times 12p upon 13 plus 30 upon 13. Now the only unknown here is p, and you need to find its value. Let's see. So I'm going to do 6 times 12 divided by 13, which gives me 72 upon 13. I'm sticking to fractions instead of decimals to avoid premature rounding. This would be 5p over 13 plus 12 into zero point 0.4 is, and oh, hold on, 0.4 times 12 by 13 is 24 over 65. Okay, so 24 over 65p plus 0.4 times 30 by 30, 12 by 30. Okay, now let's take 12 by 13 to the other side, 72 upon 13 minus 12 over 13, and take p common here. So 5 by 13 minus 24 by 65. So simplify both these fractions, 72 by 13 minus 12 by 13 is 60 by 13 is equals to p times 5 by 13 minus 24 by 65. I'll be really annoyed if I've messed up the calculation somewhere. Hopefully not. Okay. Now I'm going to take the 65 to the other side, and or in other words, times 65 on both sides. So we can have 65 here. So 65 times 60 by 13 is 300. P is equals to 300. Let me check the answer. That's so not 300. Let me try to find the mistake.